Okay, so this is the beginning of Unit 2, and specifically today we are going to focus on Section 2.1, Arithmetic Combinations of Functions. You'll notice here there's a table showing how to rewrite, going backwards and forwards, the different ways of writing sum, difference, product, and quotient. Both of them mean the same thing. So if you see f plus g of x, you can rewrite it as f of x plus g of x. They both mean the same thing. F minus g of x can be rewritten as f of x minus g of x, and so forth. Okay? So let's apply these arithmetic combinations of functions in the following manner. Let's look at these two graphs. The first graph is our f of x graph, and the second graph is our g of x graph. And we're going to evaluate what's being asked in A, B, C, and D. Notice it's a sum, a difference, a multiplication, and a division problem, just like we saw in our previous table. And we're going to apply those formulas, for lack of better words, to these problems. Okay? But let's make sure we do understand function notation. Going back to Unit 1, we knew that we were introduced to f of x being the equivalent to any output variable, let's call it y. And all this notation just means is that you are now rewriting what you used to write as x comma y as f of x equals y. Okay, so to make things a little bit more simple, in this problem in part A, f plus g of 2, let's rewrite it here so you guys understand how to read it. Okay, f plus g of 2. That's how you read it, by the way, okay? F plus g of 2 is asking us to, in essence, find f of 2 and find g of 2 and add those two values, okay? Now, but what does f of 2 and what does g of 2 mean? Well, all it means is the following. F of 2 has to equal something. It is basically asking me, given that x is 2, find what the y value is. So instead of having to write this every single time, that's what f of 2 means, okay? So in this case, find f of 2. Well, f of 2 tells us to look at our f function, all right? So they're asking us to go at x equals 2. Well, where is x equals 2? Well, x equals 2 is going to be on the x-axis at 2. And right there, they're asking you to find the y value. Well, the y value is merely going to be a 0. So f of 2 is a 0. Let's do g of 2. Well, g of 2 tells us to also go on the x-axis at 2. But that's not touching my graph. So what do? I need to move up or down to figure out what I need to do to touch my graph. And I had to go up 2 units. So I'm going to put a 2 here. So 0 plus 2 is a 2. And I'm done. Let's try that again. I'm going to erase these that we just did. Let's try that again. So f minus g of 3, that just means find f of 3 and subtract g of 3. So let's go to the x-axis at 3 for the f function. That's right here. Am I touching the graph? No, I'm not. I have to move how many units to touch the graph? Well, I had to go up 2 units. So f of 3 is 2. Let's do g of 3. Go to 3 on the x-axis. I am not touching the graph. What do I need to do? I need to go up 1 unit. So f of 3 minus g of 3 is 2 minus 1, which is 1. Now, f times g of 1 says to find f of 1 and multiply it by g of 1. All right, let's erase the one from last time. Erase and erase. Let's go to the 1 on the x-axis on the f function. And again, I have to go up 2 units. I'm going to go to the 1 on the g function. And what do? I need to go up 3 units. So 2 times 3 is 6. And on this last one, we knew we had to do f of 1 over g of 1. But if you notice, we already got the answers in part C. So just substitute those 2 over 3. So you're going to have 2 sections in Delta Math doing that, and some other sections that involve you doing the following. So look at this problem. We need to evaluate f of 7 given the function f of x equals negative 3x squared minus 7x. So what does that mean? Well, all you're doing is just substituting every x. Remember, that means that's your x value, okay? So substitute every x with a 7. And I forgot my squared here, so don't forget that squared. Use order of operations to simplify. Try and do this without a calculator, okay? And then what do we do first? Well, order of operations says parentheses, then exponents. So right here, this combination here tells me that I need to do 7 squared first. And then parentheses means I need to multiply. Negative 3 times 49, that'll be negative 147. And 7 times 7 is 49. So f of 7, which is what they were asking me to look for, is equal to negative, 196. And why is the 6 not writing? There we go. So there's my final answer. So what you basically are telling me is that when x is 7, my y value, or better yet, because we're trying to move away from xy, my f of x value is negative 196, okay? And I just want you guys to realize that it really is just basically saying your coordinate is 7, negative 196. You're just learning different ways of writing. So this right here is the same thing as this right here. Okay, those are equivalent. All right, they are equivalent. Okay, so that's example 1. Here, notice that the x value was given to you. Okay, so this here, the x value, this was given. Let me do it in all caps. This was given. Okay, so I'm going to highlight there. That was given. What happens now if, instead of it being given to you, the y value is given to you? So that's what example 2 is going to look like. Example 2, given g of x equals negative x plus 4, find x when g of x equals to negative 3. So in this problem here, notice this is given. Okay, what was given? Our output value. Or what you guys like to say, y. Our output value is given this time. So you're not substituting x with negative 3, okay? Because if they gave us an x, they would have given it to us here, okay? they didn't. We don't know what x is. That's our question mark. That's what we're looking for. But we do know what our y is. It's -3. So let's rewrite our function. So g of x has been told to be -3, -x plus 4. We're looking for the x. Basic, very simple algebra equation. I need to subtract 4 on both sides so that these become 0. -7 equals -x. And then I need to divide both sides by -1 because I need to get rid of the negative coefficient in front of my x. And so x equals +7 is my answer. That's what I was looking for, which means that in point form, my answer is 7, -3. Or you can write it as f of, no, we're doing g function. What am I talking about? We're basically saying g of 7 would give me a -3. Okay? Again, all equivalent notations. You will have, I think, maybe 3 problems on Delta Math on that. And then moving on. You will be given functions and asked to add, subtract, multiply, and divide. So we're going to do one of each. So given the function f of x is x squared plus 3x minus 40, and g of x is equal to x plus 8, let us add. All right, so there are 2 ways people do it. So some students say, okay, I know I need to add f of g plus f plus g of x. So they just write it like this: x squared plus 3x minus 40 plus x plus 8. And they look for their, like terms. So they notice that, okay, well, the 3 of x and the x stay the same, are the like terms, sorry. And I also noticed that the 40 and let's circle it instead, actually. The -40 and the -8 are like terms. So let's combine them, all right? So we combine them to, well, f plus g of x will then equal to x squared is all by its lonesome self. 3x plus x is +4x. And -40 minus 8 is -48. Okay? Oh, wait a minute. This was supposed to be x plus 8. My bad. So let's fix this here. -40 plus 8 is -32. I apologize for that. So this will be my answer for adding. I do want you to know that some students prefer doing it vertically. So if you want to write your f of x first at the top, and then you add your x plus 8 and line them up with the like terms, that also works out just fine. Let me switch up colors here to make a point. Let's use red. So the x squared comes down. The 3 and the positive x makes a +4x. And the -4 and the +8 makes a -32. Either one works, okay? Regardless of whether you write it out horizontally or vertically, you get the same answer. Same thing with, subtraction. Well, we can do f of x minus g of x. We can write it f minus g of x. Notice how I keep switching back and forth because I want you guys getting accustomed. F of x is what? X squared plus 3x minus 40 minus, and my g of x is x plus 8. So I put parentheses around it to keep them grouped together, okay? But there's something about this minus that I really need you guys to please focus on. So that's why I'm highlighting this again, okay? People tend to forget that that minus needs to be distributed to every single term that comes after it, okay? Oops. Every single term. Because if you forget to do that, then you get the problem wrong, okay? So let's do that. So x squared plus 3x minus 40, well, it has an invisible 1 in front of it, okay? So 1 times x squared plus 3x minus 40 is just going to stay the same. But that minus or negative 1 times x is going to be a negative x, and that minus times that positive 8 is going to be a negative 8. And so again, you have to combine your like terms. Well, my x's combine, and let's use a light blue. My negative 40 combines to my negative 8, and the x squared is all by its lonesome self again. So I start with the highest term, the term with the highest exponent. Positive 3x minus x is a positive 2x, and minus 40 and a minus 8 makes negative 48. Okay? For those of you that prefer vertical, well, you can do it vertically too. Write it down, x squared plus 3x minus 40. But you know there's a minus, okay? And that minus changes to a plus, and then you change the signs of everything. So the positive x becomes negative x. The positive 8 becomes a negative 8. Okay? Again, this comes down. 3 minus x is a positive 2x, and a negative 40 and a negative 8 is a negative 48. So it's just a matter of how you prefer displaying it, okay? Both methods, horizontal or vertical display, work. Let's move on. Multiplication. All right, so multiplication, let's choose purple. Purple for Timber Creek. Multiplication says that we write out, let's see, they're doing f times g of x. So we need to write down the f function, 2x minus 5, and I need to multiply it times my g function, 3x plus 1. And this is all about distribution, okay? I need you to make sure you distribute every term, okay? So let's start off with orange. The 2x needs to multiply by this term, and the 2x needs to multiply by this term. So let's do that. 2x times 3x is 6x. I'm going to go down a little bit lower, actually. 2x times 3x is 6x squared. 2x times 1 is a positive 2x. Let's use, what are we going to use? Dark green. Then do minus 5 needs to go to this one, and minus 5 needs to go to that one. So minus 5 times 3x is minus 15x. Minus 5 times positive 1, or negative 5 times positive 1 is a negative 5. We will combine our like terms. So 6x squared has no like terms. The 2x and the negative 15x, those are like terms. They become negative 13, and the minus 5 comes down. So f times g of x is this function. So just remember to distribute every single one of the terms with one another. And lastly, we move on to division. So example number 5 says that the f of x is x squared plus 6x plus 8, and g of x is x squared plus 3x plus 2. Find f over g of x. So let's do that. Alrighty. So f, ooh, that's just too light. Let's go back to black. So f of g of x, f over g of x equals, we put x squared plus 3x plus 2, and the g of x, whoops, wrong. Let's do that again. I looked at the wrong function. Bam. Let's do that. F of x is x squared plus 6x plus 8. G of x is x squared plus 3x plus 2. Okay, so one thing that just makes me die a little inside is sometimes what students do is when they see division, automatically they feel inclined very quickly to just start dividing like crazy. So for instance, they start doing, oh, look, x squareds, these can cancel. 6x divided by 3x, oh, okay, these x's cancel, and 6 divided by 3 is a 2. And then I'm going to put a plus, and then 8 divided by 2 is a 4, so my answer is 6. Okay? Don't do that. Okay? You can't just start dividing like crazy over addition. Division is only allowed when there's multiplication going on. Okay? So let's very quickly erase all that just transpired, because that's a big no-no. Okay? So let's show you what you need to do. What comes to your rescue is the term or the method of factoring. You need to factor the polynomial in the numerator, and you need to factor the polynomial in the denominator. But what if you're like, oh no, I don't remember factoring? Well, here's the thing I want you to clear up about factoring. I'm going to go back to the previous problem. What you're doing is you are being given the answer to your multiplication problem, okay? So I'm drawing an arrow right here. You are standing at 6x squared minus 13x minus 5, and I'm asking you to factor, to go back to what did you multiply to get the 6x squared minus 13 minus 5. Factoring merely just means reverse distribution, okay? You are going backwards, all right? So don't let factoring intimidate you. You are going backwards. So what times what is giving me x squared plus 6x plus 8? That's what I'm asking you. So I'm literally saying, hey, what times what would give me x squared plus 6x plus 8? And what times what gives me x squared plus 3x plus 2? Well, the good thing about this is that we have x squared terms on top and bottom, which is really easy to figure out, because what times what gives me x squared? Well, we all know x times x gives me x squared. Very simple. On the bottom, x times x. Very easy. Now, what do we do to figure out the rest of the problems? Okay, so let's figure it out. So I know that I have to be able to add two numbers to get a 6x, and I need to multiply two numbers to get an 8. Now you're probably saying, wait, how do you know that? How do I know that? Well, because going back to our previous problem, I've done this enough times to recognize that this number and this number had added to get negative 13x. Do you notice that? Negative 2x plus negative 15 gave me 13x. And this number here, negative 5, came from multiplying negative 5 times 1, which are both here at the ends, okay? So what I need to do is take that process and recognize that nothing's changing in this problem. So that what some teachers do is encourage you to create a sort of rubric over here, an organizer. And we say, okay, well, I'm going to put the what times what multiplies to be 8. So I'm going to put a dot here to remind me that I'm multiplying to get an 8. And what plus what is going to add to give me a 6. So I'm writing those two numbers from the numerator, okay? What we call the C value and the B value. So as you think about those two numbers, you are probably saying, oh, I know, my answers are 2 and 4. So you're going to take those two answers and you are going to put them in your parentheses, a positive 2 and a positive 4. You're going to do that same thing all over again. Let's do another organizer. What times what is going to multiply to be a 2? That's the last term. And what plus what is going to give me the 3, which is the middle term? Well, I figure it out. Well, I know that 2 times a 1 will give me 2, and a 2 plus a 1 will give me 3. So that works out pretty well. So I'm going to put a positive 2 and a positive 1. Now here's the great thing. I have multiplication going on now in my quotient. And now that I see that multiplication is going on, I can very happily cancel out what I want to cancel when it comes to common factors. So now I'm left with x plus 4 over x plus 1, and I don't want the denominator to ever have a 0, so I say x cannot be negative 1, okay, because negative 1 plus 1 will make my denominator 0, okay? I don't want it to be undefined. Do not do this, okay? I'm going to put it in red. Don't do this. Don't say these cancel out and my answer is 4 over 1 equals 4. No, don't do that, okay? Please, please don't. Remember, when you are, I guess I should have just undone. When you have addition, you can't cancel. So that is the answer right here to your final problem of section 2.1. So head off to Delta Math and practice these type of problems. Good luck. Watch the videos too. They provide some good videos as an aid for any things you get stuck on. Thank you for watching.